Hi, so I'm back with 3.2 and we're going to be going over surface area of pyramid, cylinders, spheres, and cones. And again, I'm just going to work through, do an example from each of the Build Your Skills and just talk about and highlight some information that you need to get out of this section of the unit. And so you'll notice that we'll have a lot of figures that have different figures kind of attached to each other, so you can tell that this one has a circle. Basically, if I put the two ends together, that would create a circle, and then in the middle there is a rectangle. So I could add up the surface area of the circle and the rectangle in the middle, and that would get me my area. There is the example there, so I'm not going to go through all of that, but I will go ahead and I'm just going to look at this example, number 2, which is on page 150. So I just made a note here. These two little tick marks mean that this side, this length here, is equal to this length here. So if I take 6.8 and divide it by 2, I get 3.4. Now, then I can also draw a line here showing that I have a semicircle, so half a circle, and a triangle as well. So I'm going to put the two areas together and get my answer that way. So again, my radius is just equal to 3.4. That's good information to know. And I found that just by dividing 6.8 by 3.4. Now, for the circle, I have half a circle, so I'm going to go half times radius, or pi times radius squared. So again, that's 1/2 times pi times the 3.4 squared. And I have to square that 3.4 right away. So what I'm going to do there is, just one quick moment here. So 3.4 squared is 11.56. And I do need to go times pi times 1/2. And that gets me 18.16. Okay, and then my triangle, I need to do the triangle as well. And that, I have a base still of 6.8. So this length across here can also go this direction. And my height is just that 3.4. Can't really see that, but you get the idea. So I know that a triangle is 1/2 times my base times my height of my triangle. And when I calculate that, I get 11.56. So now I can go ahead and I can add these two together. And in total, I'm going to have 29.72 centimeters squared. Okay. Oh, there you go. So that would be my total surface area. Going to move on. The next example does talk about cylinders. So we do have two circular bases and I call this a soup can label. That is going to be my circumference times my height. So the formula for that, if you include the two circles, is 2, because two circles, pi times radius squared. So that's the circles part, plus 2 times pi times radius. That's your circumference along the top, but then you times that by your height. So In some cases, we don't need to calculate the extra circles because they're covered up. If that's the case, then you only need to do one portion of the formula. So keep that in mind so that you're not adding in extra parts that you don't need. Okay, so let's go ahead. This is just an example using the formula. I would like to show you number 6. So in number 6, it gives one cone or cylinder on top of another cylinder with a wider radius on the bottom one and a smaller radius on the second one. I'm going to do this one down here first and just do the full thing as if it's not even covered up, and then we'll talk about it from there. So I'm going to call that, I guess, the bottom cylinder. And on the bottom cylinder, I am going to have 2 times pi times radius squared. So the 2 circles, the top and the bottom, which I don't see, but it's there, times 2 pi r h. And so put in some information that you know. The radius, to find the radius of to right here, that is going to be your 3.8 plus 4.2, which equals 8. So I'm going to use 8 as my radius, and my height is 4.8. So I get that right there. Okay, I can calculate this both individually and then add them together here, or I can just, depending on your calculator, you might be able to do more. So adding all that together, I've got 643.4 approximately. So that's the bottom cylinder. Now this top cylinder, I like to think about it as like, I just calculated that circle when I calculated my bottom one, but it's actually covered up. And so if it's covered up, this top part, instead of me taking away that portion, what if I just don't calculate the top part, right? Because I've already calculated a circle of the same size that is currently covered up. So when I do the top cylinder, if you do calculate like the 2 pi r, then you gotta end up, or 2 pi r squared, then you just have to take it away as overlap. But I'm not gonna bother doing the 2 pi r squared in this case. And if you want more explanation, just send me a quick message in the chat and I will get back to you on that one. So we're just going to go 2 times pi times radius times height. So that's the second part of the formula, because I'm not going to calculate in that top circle. Already calculated it. All right, so I've got 2 times pi. In this case, my radius is just 3.8. And my height is the 9.6. Gonna calculate all of that. I get 229.2. Now I need to add those two together. Add them. Okay, and so that is going to give me my final answer. There, 872.6 millimeters. Seems like lots. But. All right, moving on to pyramids. So pyramids are a matter of a bunch of triangles, and to do the height of those triangles, you actually need what is called your slant height. So sometimes the question will give you the height going down the center to the middle of the pyramid and straight up to what's called an apex. And in some cases, it will give you a slant height. For surface area, you want the slant height. So if it's not there, you have to calculate it using the Pythagoras theorem. So we're just going to move into some examples again on this one. So I want to just talk about 8 here for a second. Now, number 7, if we were to calculate that, it just says, what is the surface area of the square base pyramid? Well, then you need all 4 of the triangles that go around plus the square bottom. And so the square bottom is just going to be 28 times 28. Now, if I'm looking at number 8, here it says I have a pentagonal base pyramid. And in this case, it's sitting on the table, so it's only asking about the exposed area. So we also call that a lateral area. So anything that is exposed or showing. So in this case, you don't actually need to do the base. So I'm just going to calculate the 5 triangles that go around. So that's easy enough. There's 5 triangles, 1, 2, 3, 4, 5. And my formula is 1/2 times base times height. So 5 times 1/2 times my base is 18 times my height. In this case, it does give me the height, which is 28. Now when I calculate all of that by multiplying, I've just got 1,260 centimeters squared. Done. Easy, right? Okay, see how this one just says lateral for an octagon? An octagon has 8 sides, and it gives you slant height, it gives you the base. So you do not need to add in the base. If it is a square or rectangle, you might have to add in the base, but in these cases, you don't. Okay, and a few other things. You're going to start to come into some questions that do not give you the slant height, and they only give you the height. So we're going to do one like that. I'm not going to do the example it gives you because you can look at that. Let's look at this one down, number 11 here. It has a tetrahedron with basically all 4 sides are identical triangles, equilateral triangles. And so when they have these little tick marks, we saw this earlier, they have those, they mean that that is equal in length. So this is 16, 16, 16, all the way around. Okay, so if I'm looking at a triangle like this, but I need to know my height of that triangle, well, then I need to use my Pythagoras theorem. So in this case, I'm trying to find this, okay? So half of my bottom here in this case is only 8. My hypotenuse is 16, and I'm trying to find the height that's going to go perpendicular. So I need to use the Pythagoras theorem, the version of the Pythagoras theorem that goes hypotenuse squared, take away a leg squared. So 16 squared minus 8 squared. We can do those calculations. That's 256, take away 64, and I get 192, but always square root. So I've got 13.86 is my slant height. So now I've got 4 of those triangles, 1/2 base times height. So there's like 3 standing and 1 at the bottom. So 1/2, I know my base is 16, and then I just calculated my height is 13.86, and all in all, 443.52, again my units. Okay, moving on. We're going to look at cones, and so here's the surface area formula for the lateral part of the cone. If we need to know the bottom as well, then you would just add on a pi r squared for the circle on the bottom. If you do not need to know that bottom circle or include it, then cancel that out. Okay? And again, you need that slant height. So if it gives you height, then we have to calculate the slant height, okay? So I'm going to jump ahead to number 15, which is on page 162. This one says, find the total surface area of a cone with a radius of 16 inches. So there's my radius and a height of 20. So that is not giving me my slant height. So I need to find my slant height. So if I kind of draw a little diagram of this, that goes down to the middle. That is 16, and then my radius is, no, my radius is 16. This is 20, okay? So I need to find out that slant height. So I would go 20 squared plus 16 squared. Figure that out. 400 plus 256. And square root that. And I get 25.6 for a slant height. Now I can go ahead and I can use that in my surface area of this cone. So I know my surface area is pi times radius times the slant height, but then the circle on the bottom, I need to add that. Pi times radius squared. So we're going to just enter in the information I know. Pi times radius times slant height, 25.6, plus pi times radius squared. So calculate all of that. I've got okay, making sure that you're squaring your radius first before you multiply. So order of operations, of course, 16 squared is the 256, then times pi. Okay, so if you're not getting the same thing I am, that could be why. And in the end, when I put all of that together, I get 2090, but then I get 0.996. So I like to round that a little better, but I can't just leave it as a 9. So I might go 2091. Okay, and my units on this one was in inches, so inches squared. That one's done. Lastly, we do get into spheres, so like a basketball or something like that. There's your formula. 4 times pi times radius squared. Make sure you take a note of, so that's like, yeah, any kind of ball, right? So a basketball, a volleyball, a softball, anything like that. So there's your formula. Now, if you get a hemisphere, trying to draw a little circle of that, then it's going to be half, right? So it's 4 pi radius squared divided by 2. Now, that's if you don't have the bottom showing. If you do have the bottom showing and you have to calculate that, then you want to add in a pi r squared for the bottom. Moving on, I did want to do just one example regarding composite figures. So I'm going to jump ahead to example 21 on page 166 there. And so we've got 3 parts to our diagram or our composite figure. So what I have here is that sphere, but I don't actually see the circle on the bottom of that, so I don't need to include it. So again, it's 4 pi r squared, but it's a hemisphere, so it's half. So my radius in this case is half my diameter. It gives it a diameter, right? Because it's the right across. So half of that is 0.4. So I'm going to put that into my formula, 0.4 squared. Do that calculation, I get 1.005. Okay, so that's that portion. Now I can come over to this side and do the cone. Again, the cone, the bottom, I do not see the circle. It is attached and covered up. So I'm just going to go ahead and use the pi times radius times slant height. So again, 0.4 is my radius and the 1.4 is my slant height. So I can calculate all of that and I got 1.759. And very lastly is going to be my cylinder, but I don't have the two circles on either sides, so none of that and none of that. So it's just that 2 pi r times height. So we'll just put our information in, 0.4, and my height is that 2.2. Now that ends up being 5.529. Now add all of these together. And then I get a total answer of 8 point, I'm just going to round here. I could even round to 0.3 if I wanted to. And that would be my final. And I am going to finish off there, leaving you with the practice your skills. If there's like things like this with the doorway, you're not going to include the doorway, so it's going to be subtracted from your surface area. Okay, next video will be on 3.3. Thank you very much.